Hello all, welcome back. So now question is that we need to design the 2-bit asynchronous counter. So 2-bit means, so how many flip-flops are required? 2 flip-flops, right? Each flip-flop will store the 1-bit information, right? If you didn't watch previous video, please try to watch the previous video so that it will be easy for you to understand, right? So 2-bit means it is performing 0001 1011, right? It means that how many states it is performing? 4 states. That is what we called as the mod 4, right? So how many flip-flops are required? The number of flip-flop is required is 2. We need to implement by using of which flip-flop? By T flip-flop or toggle flip-flop. First step is completed. What is the second step is that we need to draw the state diagram. So state diagram means after applying the clock pulse, how it is moving from one state to the another state. So mod 4 means how many counts? So 0 0 0 1 1 0 1 1. For first clock pulse it will change from 0 to 1, then 1 to 0, sorry 1 to 2, 2 to 3. Once count is completed, it will return back to the initial position. Once it is completed, what is the next step? We need to draw the circuit diagram. How many flip-flops are required? We require 2 flip-flops. Which flip-flops are required? As per the given question, we need to design the T flip-flop. So inputs are TA, outputs are QA, inputs are TB, outputs are QB. Right? So we are considering the negative edge clock pulse. So what do you mean by asynchronous counter? The first flip-flop is triggered by the external clock pulse, and remaining flip-flop clock pulse is triggered by the output of the previous flip-flop. Then it is called as the asynchronous counter. Then one more thing, right? So if you want to change the count something 0 0 to 0 1 1 0 1 1 means the value should be changed from either 0 to 1 or 1 to 0, right? So it means that changing the value from 0 to 1 or 1 to 0, what we called as the toggle condition, right? So by using the T flip-flop we have the toggle condition, right? But if we take T flip-flop, we have the two inputs. One is T equal to 0, T equal to 1. So T equal to 0 means it will not perform the toggle condition. It means that if you are considering T equal to 0, it will not change the count from 0 to 1, 1 to 2 or 2 to 3. Now what is the condition we have to take? T equal to 1, then only toggle condition will occur, so that your count will change from 0 to 1, 1 to 2, 2 to 3, then 3 to 0. Right? So what is the value we have to connect? TA should be 1, TB should be 1. Instead of giving two external values, just I am connecting the both terminals are same, then it will be 1. In previous classes what we have done? We have connected the JKA1, JBKB1. Because here T flip-flop means only single input, means just we are connecting TA to 1, that's it. That's the only difference. Remaining everything will be same. So this is the circuit diagram for the 2-bit or mod 4 asynchronous counter. Now what is the next thing? Operation, right? So operation means what is the initial value of the flip-flop? Something you are taking the 0 0, right? Before applying the clock pulse value. After applying the 1 2 3, sir, 4 stages means how many clock pulses are required? 4 clock pulse. For the first clock pulse it will change from 0 1, then 1 0 1 1, then finally it will return back to the initial position, right? So clearly I have explained in the previous classes. If you didn't watch the previous class, try to watch that class so that you will be understanding how it will change from 0 to 1, 1 to 0, right? So 1 to 2, then 2 to 3, then again it will return back to the initial position. You will understand. Once it is completed, next what we have to do is we need to draw the timing representation, right? So output is depends upon QS, depends upon what? External clock pulse, right? So first I am going to consider the external clock pulse value, right? So it means that clock pulse means 0 1 consecutively it will change, right? Which edge triggering mechanism we are using? If you observe here, this is the clock pulse, right? This is nothing but the negative edge mechanism. So this is the negative edge, negative edge, negative edge, negative edge representation, right? So this is the starting ending, then starting ending, starting ending, starting ending, something. So if you want to find the output of the QA, it is depends upon the what? External clock pulse. This is also clock pulse only, right? So before starting this value, here only it is starting. So before that it will be 0. After 0 what is the value? 1. After 1 what is the value? Clock pulse means 0 1 only, right? After 0 1, after 1 0. This is also clock only. Now what is the output? We need to find out QB, right? This is a QB, right? QB depends upon what? This clock pulse, where it is coming? It is coming from QA. It means that we should not consider the external clock pulse, we should take the reference of the QA. It means that we need to find out the negative edge mechanism for the QA, that's it. So this is the negative edge for Q array, this is the negative edge for Q array, this is the starting clock pulse, this is the end clock pulse. Before this, what is the answer? 0. After this, what is the answer? 1. So during this time period only, this is 1. After 1, then remaining will be 0. This is the timing representation for the mod 4 asynchronous counter or 2-bit asynchronous counter. Thank you.